Dear student, welcome to the YourPedia. Today I am going to just introduce some of the interview questions which is important for your research exam, just like a DRDO, NPCIL, ISRO and so on. है ना? So basically we are just going to focus to make that video to focus on the RAC or a DRDO examination. So basically this question is generally asked in the case of a DRDO examination. So the question is simple one. They have some way to ask the question. They are just asking the simple question or the basic question initially, and after that they are just going to increase the level one by one. है ना? They are just going to ask the question in a depth. है ना? Initially वो आपसे थोड़ा सा पहले इजी क्वेश्चन पूछेंगे, देन उसके बाद वो डेप्थ में एंटर करते जाएंगे, वन बाय वन उसके अंदर क्वेश्चन पूछ जाएंगे. सो आई एम जस्ट गोइंग टू इंट्रोड्यूस द वन क्वेश्चन लाइक दैट. सो the question is simply saying that what is the Bernoulli equation. So as I all know about that, Bernoulli equation is just known as a mechanical energy balance equation. Mechanical energy balance equation. In this equation what will happen? Ki there is a pressure energy, sum of pressure energy plus kinetic energy plus potential energy remains constant. So that is known as also known as a mechanical energy balance. Okay, so what is the Bernoulli equation? It is just a mechanical energy, but it will just cover up the pressure energy, kinetic energy and the potential energy. We are just talking about one by one. So the next question is that what are the various assumptions in the Bernoulli equation? What are the various assumptions in a Bernoulli equation? So the first assumption should be the flow should be steady. Second, the flow should be incompressible. The flow is irrotational. The flow is non-viscous and the flow should be continuous. Should be continuous. So they can asking according to that what are the various assumptions under the Bernoulli equation can be derived. So Bernoulli equation is generally not be derived by a single one. So initially we are just considering the Navier-Stokes equation, where we are just considering the different type of forces, just like a pressure force, gravity force and the viscous force. By neglecting the viscous force, we are just going to the Euler equation. We are just going to the Euler equation. On doing the integration, we are just getting the Bernoulli equation to the Euler equation. Okay. So they are just going to be asked, what do you mean by a steady flow? What do you mean by a steady flow? What do you mean by a steady flow? So the flow is said to be a steady flow when it does not vary, its property or its flow does not vary with respect to time at any given section. At any given section. That type flow is known as a steady flow. So they can ask some question like that, if I am just making a one converging passes like this, okay, and taking the two section at t equals to 1 second, at t equals to 5 seconds, at initially t equals to 1 second. Here the velocity is 2 meter per second and here the velocity is 3 meter per second. So is this a steady flow or unsteady flow. So we can't say about that until or unless we are not know about that with respect to time the properties or the velocity is going to be changed or not. If the time is going to be increasing, just let us assume that t equals to 4 second ho gaya. Now here the t equals to 4 second. If the velocity remains constant 2 meter per second, if the velocity remains constant 3 meter per second, so that the flow is known as a steady flow, otherwise it is known as a unsteady flow. Okay. Sometimes they also ask about some other assumptions. What do you mean by a compressible flow? So we know about what do you mean by compressible flow. So compressible is equals to the rho is constant. Rho is constant. Yani density should be constant, है ना? Or they can ask about the what is the Mach number for the incompressible fluid. What is the Mach number for the incompressible fluid? So you should know about that. Ki Mach number for an incompressible fluid should be less than the 0.3, should be less than the 0.3. Or it maybe they can ask what do you mean by a irrotational flow or rotational flow. So a flow is said to be irrotational if a flow is said to be a rotational flow if their masses are rotating about their center of mass. They are rotating about their center of mass. अगर वो अपने center of mass के about rotate कर रहे हैं, let us assume there is a one point A, there is a second point B, there is another point C. If they are just going to rotate about their center of mass, then it is known as a rotational flow. Otherwise, it is known as a irrotational flow. Okay. So these are some assumptions they can ask. After that, what are the different types of head in a Bernoulli equation? So as I know about that, ki Bernoulli equation equals to P1 by rho z plus V1 square by 2g plus Z1 equals to P2 by rho g plus V2 square by 2g plus Z2. So they are the energy in the form of head. We are just writing the energies in the form of head. Just like ki P1 by rho g is representing the, yeah, P by rho g is representing the pressure head, is known as a pressure head, or Z1 is representing the potential head, potential energy head, and V1 square by 2g is representing the kinetic head. Okay, if we are just written that is P1 by rho g, yeah, P by rho g plus Z, that is known as a piezometric head. That is known as a piezometric head. So here we are also writing the energy in the form of head, and the different energies representing by that. Ki pressure head, P by rho g is representing pressure head, Z is representing the potential head, V1 square by 2g representing the kinetic head, and P1 by rho g plus Z is representing the piezometric head. Next, what is the HGL and TEL? What do you mean by a hydrodynamic gradient line and total energy line? है ना? What is that? So that is when I am just talking about the hydrodynamic gradient line. So let us take, I am just taking the one example of a flow in a pipe. Just like there is some flow in a pipe. So when we are just considering P1 by W and Z1 from here to here, similarly this is also piezometric head from here to here, that is representing the hydrodynamic gradient line. And when we are just combining the kinetic head or the velocity head here, that is V1 square by 2g, it is also the V2 square by 2g. So that is become a, this is HGL or this is TGL, है ना. This is known as a hydrodynamic gradient line and this is known as a total energy. So hydrodynamic gradient line is a locus of the all piezometric heads or the all piezometric heads, whereas just I am talking about the total energy line. So total energy line will combine the all piezometric head plus kinetic head. So the next question they are just going to be asked under this is like that. What is the HGL and TGL in the case of a pump and the turbine? Pump and the turbine. So हमारा जो hydrodynamic gradient line है या total energy line है, both are the same thing here in that case. So we can say that कि how it is going to be vary in the case of a pump or a turbine. So as I know about that, कि turbine is a device which is just going to be convert the some kinetic energy into the, जैसे कि हम वहाँ पर क्या करते हैं, डैम बना के पेनिस्टॉक से सम पोटेंशियल हेड को प्रोवाइड करते हैं एंड दिस इज कन्वर्टेड टू द रोटर पावर और ये हमारा एनर्जी को प्रोवाइड करता है. सो हमारी एनर्जी कहीं ना कहीं कन्वर्ट हो रही है, एक हायर एनर्जी स्टेट से आ रही है एंड देन गोइंग टू बी डिक्रीजेस इन द केस ऑफ turbine. So we can say that in the case of a turbine the energy gradient line is going to be decreasing, whereas in the case of a pump what will happen, initially जो वाटर के पास या जो मेरे फ्लूइड के पास एनर्जी होगी वो कम होगी, आफ्टर गेटिंग द सेंट्रीफ्यूगल एक्शन दैट इज गोइंग टू बी इंक्रीजेस. सो इन दिस केस इट इज गोइंग टू बी increase. So in the case of a pump or a turbine, total energy line or a hydrodynamic gradient line is going to be decreases, whereas in the case of a pump it is just going to be increases. So can we apply the Bernoulli equation for a real fluid? Yes, we can apply the Bernoulli equation for the real fluid by applying the head loss, whatever the losses are going to be occur in the, so we can just write like this, P1 by rho g V1 square by 2g plus Z1 equals to P2 by rho g plus V2 square by 2g plus Z2 after if we are applying the some head loss or the whatever the loss occurring due to the real fluid. When we are just considering the real fluid, there is some loss will occur if we are just considering that one, so we can apply for the real fluids. Next, can we apply the Bernoulli equation in the case of free vortex or forced vortex? As we know about it, what is the meaning of free vortex and forced vortex? Free vortex is just like a flow of fluid in a whirlpool या रिवर के अंदर जो फ्लो होता है हमारा, जस्ट लाइक जो बवर फॉर्म होते हैं यानी नेचुरली फॉर्म हो रहे हैं. वेयरएज व्हेन आई एम जस्ट टॉकिंग अबाउट द फोर्स वोर्टेक्स मेरा कौन होता है कि जब मैंने बकेट के अंदर अपना एक टॉर्क प्रोवाइड करके या हैंड को इस तरीके से रोटेट करा के एक प्रेशर हेड को डेवलप कर दिया, दैट इज नोन एज द फोर्स वोर्टेक्स. मतलब मैं यहाँ पे कुछ ना कुछ एक्सटर्नल मीन यूज कर रहा हूँ, यानी मैं यहाँ पे कुछ टॉर्क को यूज कर रहा हूँ और यहाँ पे क्या है, नेचुरली हो रहा है. सो देयर इज नो अनदर एनर्जी विल बी प्रोवाइडेड इन द केस ऑफ फ्री वोर्टेक्स. सो वी कैन अप्लाई द Bernoulli equation in the case of a free vortex, whereas in the forced vortex there is some torque or some force can be applied or externally applied, so we can't apply the Bernoulli equation in the case of the forced vortex. I think there are some questions which are just going to discussing according to the Bernoulli equation. We are regularly discussing some of the more important questions according to the different topics. So please join us and enjoy the different questions for the RAC examination or DRDO examination and smooth your preparation. Thank you so much for joining us.